Hello everyone, and welcome to Asombro's virtual open house. We've missed being able to gather with you, our friends, our community, our donors, and our volunteers, and we just wanted to share with you some of what we've been doing this fall. So I'm Kelly, and I'm here today with Ryan and Steph and Stephanie, and we're going to show you some of the lessons that we've been working on. In a typical school year, Asombro staff would have spent the fall working with students all around southern New Mexico, in classrooms, schoolyards, and on field trips, getting them engaged in science investigations and excited about investigating the world around them. As you know, we've been doing remote learning this year, which means everyone has been learning from home and teaching from home. And that presents a lot of challenges. Teachers have to adapt, they have to find new ways to engage students from a distance. Students have to work harder to stay focused and engage themselves in the learning. It's a lot harder, and they're not always logging on, they're not always turning in their work. What we've heard from the school district is that there's a real focus on literacy and math. And so there's not as much focus, especially at elementary school, on science. It's not as high a priority for many people. And of course, it's been a hard year for everyone. Resources are scarce. And we have to make sure that everyone has the basics covered, that they have a computer, that they have enough food, and there's not always room for other supplies. But of course, we have not taken any of those challenges lying down. Asombro has been working really hard this year to make sure that what we're doing is interdisciplinary, that we are giving teachers lessons where they can learn science while also talking about nouns, that they can practice their math while graphing the data they're collecting. We are working on how do we supply kids with the tools that they need to do science. So we've delivered thousands of at-home science kits. You can see in this picture Anne delivering kits to an elementary school so that students have the supplies they need to do a lesson at home that we walk them through via a video. And then they can answer questions and do assignments that they can turn in to their teachers. And we've been learning a lot. We've gained a lot of new skills. We've learned how to use different tools so that we can teach kids even when we can't see them. And that's been not only really fun, but really exciting for Asombro because it means that we've been able to spread our reach. We're working with students in Albuquerque, students in Lovington. We'll be able to continue to work with students farther from Las Cruces because we've got lots of ways to reach them now. So Ryan and I are here today to show you a few of the lessons that we've been putting together, that our volunteers have helped put together thousands of science kits for, and we've delivered to elementary schools and middle schools throughout Las Cruces and southern New Mexico.
All right, good morning again, everybody. So the first program I wanted to talk about was Desert Stories, second grade. Now, the Desert Stories programs are something that's very near and dear to my heart because it does take science concepts and interweaves math and language arts into these programs. So there was a bit of a challenge trying to turn this into a remote lesson, but we were very happy that we were able to keep a lot of the aspects the same, even though it looks a little bit different in this remote setting. So they are still learning the story of seed dispersal, but they are getting to work with adjectives to learn how to describe what they see and discover. And also they're getting to work on measuring, which is a major math standard for second grade. So they do a couple of different activities. And I don't know if we wanted to move off of this. Okay. All right. So if you were a volunteer, you may have put these together. There were the little seed cards that you taped to the back of a museum card. So what the students do with these is they get one separate piece of paper. And I'm sorry you can't see it, but down here, I wrote it in here, but they put their seeds in these little circles down at the bottom of their page, and they gently blow on them. That was not super gentle. But then they did take that paper ruler, and we included a paper ruler just to make sure that this was a piece of equipment they had, and we didn't want to have to depend on them having a ruler at home. So they take their paper ruler, and just like the in-class version, they measure how far their seeds fly, and then figure out how to describe what they found about how these seeds move with adjectives. And then the other activity that they get to do, I'm not sure how many of you got to see this part of it, but they put a sock over their shoe and they go outside and they walk around a little bit, and lots of little seeds and grass pieces and whatever get stuck to the bottom of their shoe, and then they sort that to figure out how many different types of seeds could they possibly disperse in their neighborhood. And we do a little bit of math with that and counting and sorting and things like that. And then finally, at the end of it, we deem them seed experts, and now they get to solve a problem in which they take their little cups of Play-Doh that we also use in the in-class program, and they design their own seed based on what they've learned about different structures that seeds have that help them move. So if you want to go back to the PowerPoint, Kelly. So you can see on the left-hand side, that is the sock experiment results that we got from a teacher. She sent us some pictures of some student work. So you can see some examples of what they did. They obviously got a lot of things on their little socks. They grouped them together, and just like we showed them in their video, they were able to quantify how many seeds they could help disperse. And then over on the right-hand side, you can see some examples of some seeds that students made after going through this program. So at the very end, they took their Play-Doh, made their seeds based on what they learned, and described what they found. All right. Remove the seeds from the tape on the back of your museum card. The yucca seed is black, flat like a pancake, and shaped similar to a capital D. If it gets water and sunlight, it might become an adult yucca plant. The mesquite seed is brown, round like a biscuit, and shaped like a diamond. If it gets water and sunlight, it might become an adult mesquite plant. You may have heard the Spanish name for this plant, mesquite. These seeds are a similar size, have a similar shape, and both need to disperse.
The next thing a scientist does is make a hypothesis.
All right. Thanks, Ryan. Yeah, so I am going to tell you a little bit about our 7th grade program we put together this fall. This one was really fun. We worked in collaboration with the NMSU Herbarium to create a lesson on creosote bush genetics. Of course, the title being, Do These Genes Make Me Look Big? So there's this really cool phenomenon where if you go to the Mojave Desert in California or the Sonoran Desert in Arizona, you see different sized creosote bushes. They're all the same species, but the bushes are different sizes in different deserts. And that has to do with because the number of chromosomes in each cell of the plant. So a bush from the Chihuahuan Desert here where we live has 2 sets of chromosomes, which is like we have, one set from our mother, one set from our father. But if you go over to the Sonoran Desert in Arizona, they have 4 sets of chromosomes. They get 2 from their mother and 2 from their father. So anyways, it's just this really interesting phenomenon that happens to be very prevalent to where we live. And so we put together a genetics lesson with the herbarium where we had students looking at herbarium samples that have been digitized. So this is, scientific collections, scientific specimens all over the country, from all over the world, where the researchers just take a really good picture and put it online. So we had students looking at those samples and measuring the size of the branches. on their computer screen. And so they were measuring the samples so they could compare the size of the bushes throughout the 3 deserts, and then had to investigate, why is that? Is it because something like genetics that's intrinsic to the plant, or is it because like they just get more water and that's why they're bigger over in the Mojave Desert? So if you helped put together these kits, you might recognize we had 4 samples, and then we put these little strips of filter paper and just a marker line, a different colored marker line on each filter paper. So these are our DNA samples. And if you're studying DNA, if you're analyzing it through electrophoresis, you put your DNA sample in a gel, you run electricity through it, and the DNA separates based on the size. The DNA moves, like small pieces move quickly and far, and big pieces are heavy and they don't move as far. So we used a model where instead of putting it in gel and using electricity, we put our DNA sample, our marker, on paper, and we put it in water. So students took those strips of filter paper, they attached them to a popsicle stick, and they just put it in a cup of water, and they let that water soak up through the filter paper. And I'll show you, the ink separates. So this was originally a black line, but it separated into blue and green and red ink. So the different colored marker inks separated differently to different patterns. And that was what we had students looking for, this idea that DNA causes different patterns when you separate the components of a sample, if that makes sense. So we had them comparing DNA samples and determining what's different. And we had them looking at maps of how much precipitation did this bush get, and stuff like that. We had them investigating a lot of things on their computer and by hand. This is a brand new lesson for us. We weren't adapting from the classroom. We were doing something totally new. But we also had videos, and we had interviews with the scientists, and the teachers have told us they're really excited about this. So it was a lot of fun to put together.
Remember our example with the Chihuahua and German Shepherd puppies? In our model, you would see results like this: 2 similar DNA samples from the German Shepherds and 2 similar DNA samples from the Chihuahuas. In real gel electrophoresis, you would see results that look something like this. You have 4 DNA samples, 2 from the Chihuahuan Desert, 1 from the Sonoran Desert, and 1 from the Mojave Desert. If DNA determines the size of the creosote bush, different sized plants will have different DNA patterns. Remember that the average size of creosote bushes in each desert is different. So if the plants in the 3 deserts have different DNA, then DNA likely determines at least some of the differences in shrub size. If all the plants have the same DNA, then something else determines the size of the creosote.
All right. All right, so the 4th grade lesson is called Let It Blow. And this is a brand new lesson based off of some research, a research partnership that we have with Dr. Nick Webb at NMSU, and looking at how ground cover can affect the amount of dust erosion that we experience here in the desert. So we start off with giving the students at least a little bit of background knowledge on or awakening that background knowledge that they know what dust erosion is, they've experienced it, and then just sort of trying to explain it. All right, and yes, thank you, Kelly. So if you put together these little pink boxes, thank you. That is what this lesson was for. So the kits for this lesson, it is a small Tupperware container, and it's got, and also if you gave us chads, thank you. It's got the paper chads in there representing dust in this model. Then they put their little dust collector inside of this container on top of the dust. I'll see if I can do this not on the table. They have the straw that's they're going to be modeling the wind through that. So they take the straw and hold that on there and blow through it. And if I can show you guys. Those little chads fly all around this container, and then they collect the dust inside of the dust collector. You can see I've got a few of them there. And they are able to quantify how different types of ground cover affect the amount of dust is created. So me just blowing into that one was an example of there being no ground cover on over the soil. And they also use pipe cleaners to model other types of ground cover. So they'll take their pipe cleaners and load them into a zigzag and lay them inside of that container to model a grassland, or they'll take them and twist them into a ball to represent shrubs in that grassland. So we have them do 3 trials, a grassland trial with the zigzag pipe cleaners, a shrubland trial with the balled up pipe cleaners, and then a bare ground trial. And then based on what they learn, they do another trial that's an engineering challenge where they have to try and come up with some way to stop erosion of that soil. So if you want to go back to the PowerPoint, Kelly, there's an example there. I believe that is Wesley's example because he did this with his class, and his solution was to cover it with cereal. And I believe he was modeling an ancient form of soil erosion control of lithic mulch gardening. So of course, Wesley, I appreciate the using of cereal. I probably would have done something similar if I were in his class. And then just to give you guys to let you guys know, we did follow up with a lot of the teachers that we use this with a survey to just kind of get their feedback on where we could improve this, where were the pieces missing. And this one 4th grade teacher wrote back saying that the gist of it was that this was a very good, simple way of teaching this phenomenon, and that she felt her students walked away with a greater understanding of the concept and were able to apply it to other things that they were learning as well. So that is Let It Blow. All right, and I'm passing it off to Kelly again.
All right, awesome. Elementary lessons, they just look like so much fun. I mean, I have fun with my lessons, but I don't get to like make a bunch of tiny paper boxes and stuff for middle school, but I get to give them magnets. So with 8th grade, we had a lot of fun. Again, this was a brand new lesson that we developed this year for 8th grade on magnetic fields. And it was kind of a crazy idea. We knew we needed an 8th grade lesson that fit into this part of the semester. And so magnets was a good fit. And I went, I read an article in National Geographic once about how birds have like magnetite in their beaks and it helps them migrate and navigate. And we kind of ran with that for a long time. And it turned into something really fun about magnets and migration. And so one thing I'm not sure we mentioned is for all of our lessons, we set it up so that we give the students the kit. They go online and they watch videos about how to use it. They watch videos for the background knowledge they need. And as they're watching the videos, they're answering questions, and then they're doing their investigation with their kit. And then they maybe are watching another video with a scientist explaining what scientists see when they do that sort of investigation or something like that. So there's a lot more than just giving the students the kits, but giving them a lot of background and instruction. So we, for this lesson, gave students information about magnetic fields and why does a compass point north, and how does the Earth's magnetic field move things around the Earth or impact things like a compass. And so we gave the students a paper with a little tiny compass and a little bar magnet, and many of you helped by taping these together and putting some little iron filings into a bag. Sorry, let me come out of screen share so you can see me bigger. I forgot. And if I move this, let me figure out where to put the paper. There we go. So we asked students, how does the Earth's magnetic field move things? How does it exert a force? And so we had them put their magnet down and play around with their compass of, if I move the compass to different places, what happens. And I know you can't see because it's a tiny compass, but I'm sure you guys know that as you move the compass around, the north arrow starts pointing different places. And then we give them a little picture of the Earth here and put our compass underneath, or actually I'll put it on top. And we figure out that if you move the compass around, it's gonna point towards a certain end of the compass. So a certain end of the magnet. So which way does the magnet go on our model? And then we gave them iron filings, so we had them visualizing the Earth's magnetic field around the compass as well. And I don't know, I just thought it was so exciting that I got to play with iron filings, and hopefully 8th graders thought that was ridiculously fun too. Then after all this, we then talked about how we talked with an ornithologist, and we talked about how there's lots of ways that birds might use the Earth's magnetic field to migrate. There's lots of animals do. There's evidence that monarch butterflies use the Earth's magnetic field. Bacteria that migrate up and down, like from the top of a pond to the bottom of a pond, use the Earth's magnetic field. There's evidence that deer use it when they're traveling. So we just kind of explored, like, how do different animals maybe sense the Earth's magnetic field? And the really cool thing with birds is that they have a protein in their eye that when light hits it, they can actually visualize the Earth's magnetic field. So it's called a cryptochrome, and it's this little protein that allows them to see the field in front of them and kind of gauge which direction they're looking. That's the theory, at least. It's still definitely a very poorly understood part of bird anatomy. But we had the students looking at this and then helping doing kind of a choose your own adventure game to help a hummingbird migrate from its summer home here in New Mexico down to its winter home in Mexico. So that was 4 of the lessons that we made kits for, and I know many of you helped out with that. So we wanted to show you what we're doing and let you know that, as Stephanie said earlier, we've had such a good response from teachers. We know their students are getting hands-on science when they weren't necessarily going to, if we couldn't offer this. There's so much going on, but it's hard to get students materials this year. Teachers can't just give them something hands-on to do or assume that they have the stuff at home to do something hands-on. For example, we can't assume students have a ruler at home, so we made a paper one for them. So we've had such a really great response. We've been asking teachers for responses. Ryan, anything you want to add on this slide?
So one of the questions we did ask them was if they thought the access to kits helped engage their students, and overwhelmingly teachers said yes. The average answer was like 9.4 with a range from like 7 to 10. And we did give the teachers an opportunity to add other comments in an unstructured format, and many of them said, and we've got a sample around that around the slide where yes, we loved them. The kits were amazing. Please give us more. So they want more lessons like this, and they want to do more science activities like this with their students.
Yeah, absolutely. So thank you all for supporting that and helping us make that happen. We definitely couldn't do it without you guys. We've put together, I think my last count was about 5,500, so 5,000 plus kits and distributed this year. And that's kits that we've sent out. We have provided other lessons that don't require kits, that were just all online. So we've been learning a lot and reaching a lot of students this year, despite the struggles that we've been having, and just of not being able to get into this classrooms like we normally would. And one of the things that's really exciting, like Stephanie mentioned, is we've been able to really spread our reach. we've been able to reach out to teachers that we wouldn't necessarily be able to drive to. It just wouldn't be practical for us to get to their classroom, but we can send them a lesson and we can send them some kits. And lots of tools that we'll be able to use into the future. This is not creating lessons that are only applicable during the pandemic. We'll be continuing to use these models and these new online tools that we've been developing. A few things, if you guys have students in your lives who are bored for Christmas break, for winter break or something, and you want to send them to asombro.org/science. There's some activities that students can do at home with just materials they are likely to find around the house, including a mini data jam. Debbie mentioned helping out with last year's data jam. Or a couple years ago data jam. We weren't able to host the competition last year just because of the timing of when schools closed and all the uncertainty. But we did put together a mini data jam. So anyone can now do a mini data jam at home, take some data and create a fun project with it. And then looking forward to 2021, we've got new lessons we're putting together with online lessons and kits for students. I know Ryan's working on a 3rd grade. I'm working on a 7th grade one. We're working on adapting our normal 3rd grade desert stories and 7th grade white sands lizards lessons for this spring. And then we are going to have a desert data jam this year. It'll look different and we won't be able to gather in person, but we'll definitely be asking for volunteers to help judge and look through all the projects and see what students can come up with in their new settings, what they're able to do. So again, just thank you all so much for your support, whether you've donated your time or your treasure to us or both. We couldn't do any of this without our community, and you are our community, and it's just so lovely to see you all here today. Yeah, I can't say anything but thank you. I'm sure many of you have received a letter from us recently about our end of the year fundraising campaign. So if you feel you would like to give, you know where we are. We just can't thank you enough for everything you've already given to us. It's been so helpful.